Hi and welcome to IMS. We are at Anritsu booth today and we are showing a lot of new products, and one of them actually is the state-of-the-art Anritsu Vector Network Analyzer. This is a very unique solution. We have released this product, the 70 kilohertz to 220 gigahertz in a single sweep for quite some time now. This year we are actually bringing out a full 4-port differential 220 gigahertz single sweep VNA. We are the only one that can actually make differential measurements right up to 220 gigahertz. And what you can see here is a 70 gigahertz mainframe VNA. And then we have our millimeter wave module, and as you can see, the frequency coverage from this module is 70 kilohertz right up to 110 gigahertz. This is a real millimeter wave module, and the mainframe signals or the main signals from the main VNA are up to 54 gigahertz, and then we do the multiplications right inside the module. This is based out of nonlinear transmission line technology, which is patented to Anritsu, and because this one goes up to 110 gigahertz, this is a 1 millimeter interface. In almost the same form factor, we can actually cover from 70 kilohertz to 220 gigahertz in a single sweep, which is very useful for people doing device modeling and device characterization for D-band and G-band applications. But we don't stop there. We actually go from 70 kilohertz right up to 220 gigahertz in a single sweep. You can make single-ended measurements, or you could also make true differential measurements based on two sources coming from the VNA, of which you can control the phase, and you can have true differential input to your devices. Just to give you a closer look, since we have to cover from frequency ranges from 70 kilohertz right up to 220 gigahertz, you can see that the center conductor here is a 0.6 millimeter. The flange that you are seeing is only for mechanical alignment with the probes and other devices, but the main center pin here is a 0.6 millimeter. So this system can work as a 2-port 220 gigahertz system. If you have one of the modules here, the same module there, you have a 2-port 70 kilohertz to 220 gigahertz in a single sweep. However, you could upgrade any time from a lower frequency to a higher frequency, and then the number of ports as well. If you go to 220 gigahertz 4-port system, you will have 2 of these modules on the left and 2 on the right, and we have differential 70 kilohertz to 220 gigahertz probes coming from MPI, who's our partner. For a single-ended, it's a GSG. For a differential, it's going to be a GSGSG. So that's a very unique solution. Now, what we are also trying to show in our booth today is a hybrid combination wherein on one side you could have a banded VDI millimeter wave module, and on the other side you could have a broadband receiver module, so that in case you have devices going up to say D-band or G-band, and the requirement on the input side is say more than 0 dBm, or it's waveguide in nature. So for that kind of application, you could use on the transmit side a VDI millimeter wave module that again could be from 110 to 170, or it could be a 140 to 220 gigahertz, and then you can make fully vector corrected S parameter measurements. For the millimeter wave modules here, by default, our interface here is a 0.6 millimeter connector, which is out of the world, because if you have to support coaxial measurements or broadband measurements from 70 kilohertz to 220, the connector size has to be very, very small. However, as I mentioned, there could be customers asking for waveguide applications or waveguide interfaces. So here what we have is a shim that on one side is a 0.6 millimeter, and then on the other side is a waveguide measurement solution. So this is actually a very unique solution. The upgradability in the frequency and the number of ports is there. The system is based out of Anritsu patented technology called as nonlinear transmission line technology, and that gives us really high stability over temperature and time measurements.